Impact factor.
The impact factor of an academic journal is a measure reflecting the average number of citations to recent articles published in the journal. It is frequently used as a proxy for the relative importance of a journal within its field, with journals with higher impact factors deemed to be more important than those with lower ones. The impact factor was devised by Eugene Garfield, the founder of the Institute for Scientific Information. Impact factors are calculated yearly starting from 1975 for those journals that are indexed in the Journal Citation Reports.
Calculation.
In any given year, the impact factor of a journal is the average number of citations received per paper published in that journal during the 2 preceding years. For example, if a journal has an impact factor of 3 in 2008, then its papers published in 2006 and 2007 received 3 citations each on average in 2008. The 2008 impact factor of a journal would be calculated as follows. Note that 2008 impact factors are actually published in 2009. They cannot be calculated until all of the 2008 publications have been processed by the indexing agency. New journals, which are indexed from their first published issue, will receive an impact factor after 2 years of indexing. In this case, the citations to the year prior to Volume 1, and the number of articles published in the year prior to Volume 1 are known zero values. Journals that are indexed starting with a volume other than the first volume will not get an impact factor until they have been indexed for 3 years. Annuals and other irregular publications sometimes publish no items in a particular year, affecting the count. The impact factor relates to a specific time period. It is possible to calculate it for any desired period, and the Journal Citation Reports, JCR, also includes a 5-year impact factor. The JCR shows rankings of journals by impact factor, if desired by discipline, such as organic chemistry or psychiatry.
Use.
The impact factor is used to compare different journals within a certain field. The ISI Web of Knowledge indexes more than 11,000 science and social science journals.
Criticisms.
Numerous criticisms have been made of the use of an impact factor. For one thing, the impact factor might not be consistently reproduced in an independent audit. There is a more general debate on the validity of the impact factor as a measure of journal importance and the effect of policies that editors may adopt to boost their impact factor, perhaps to the detriment of readers and writers. In short, there is some controversy about the appropriate use of impact factors.
Validity is a measure of importance.
The impact factor is highly dependent on the academic discipline, possibly on the speed with which papers get cited in a field. The percentage of total citations occurring in the first 2 years after publication varies highly among disciplines from 1 to 3% in the mathematical and physical sciences to 5 to 8% in the biological sciences. Thus impact factors cannot be used to compare journals across disciplines. The impact factor is based on the arithmetic mean number of citations per paper, yet citation counts follow a Bradford distribution, that is, a power law distribution, and therefore the arithmetic mean is a statistically inappropriate measure. For example, about 90% of Nature's 2004 impact factor was based on only a quarter of its publications, and thus the importance of any one publication will be different from, and in most cases less than, the overall number. Furthermore, the strength of the relationship between impact factors of journals and the citation rates of the papers therein has been steadily decreasing since articles began to be available digitally. This problem was exacerbated when the use of impact factors is extended to evaluate not only the journals, but the papers therein. The Higher Education Funding Council for England was urged by the House of Commons Science and Technology Select Committee to remind research assessment exercise panels that they are obliged to assess the quality of the content of individual articles, not the reputation of the journal in which they are published. The effect of outliers can be seen in the case of the article A Short History of SHELX, which included this sentence: "This paper could serve as a general literature citation when one or more of the open-source SHELX programs, and the Bruker AXS version Schelkstal, are employed in the course of a crystal structure determination. This article received more than 6,600 citations. As a consequence, the impact factor of the journal Acta Crystallographica Section A rose from 2.051 in 2008 to 49.926 in 2009, more than Nature, at 31.434 on Science, at 28.103. The second most cited article in Acta Crystallographica Section A in 2008 only had 28 citations. Finally, journal rankings constructed based solely on impact factors only moderately correlate with those compiled from the results of expert surveys. It is important to note that impact factor is a journal metric and should not be used to assess individual researchers or institutions.
Editorial policies that affect the impact factor.
A journal can adopt editorial policies to increase its impact factor. For example, journals may publish a larger percentage of review articles which generally are cited more than research reports. Thus review articles can raise the impact factor of the journal, and review journals will therefore often have the highest impact factors in their respective fields. Some journal editors set their submissions policy to by invitation only to invite exclusively senior scientists to publish citable papers to increase the journal impact factor. Journals may also attempt to limit the number of citable items, that is, the denominator of the impact factor equation, either by declining to publish articles, such as case reports in medical journals, that are unlikely to be cited, or by altering articles, by not allowing an abstract or bibliography, in hopes that Thomson's Scientific will not deem it a citable item. As a result of negotiations over whether items are citable, impact factor variations of more than 300% have been observed. Interestingly, items considered to be uncitable, and thus are not incorporated in impact factor calculations, can, if cited, still enter into the numerator part of the equation despite the ease with which such citations could be excluded. This effect is hard to evaluate, for the distinction between editorial comment and short original articles is not always obvious. For example, letters to the editor may refer to either class. Another less insidious tactic journals employ is to publish a large portion of its papers, or at least the papers expected to be highly cited, early in the calendar year. This gives those papers more time to gather citations. Several methods, not necessarily with nefarious intent, exist for a journal to cite articles in the same journal which will increase the journal's impact factor. Beyond editorial policies that may skew the impact factor, journals can take overt steps to game the system. For example, in 2007, the specialist journal Folia Phoniatrica et Logopedica, with an impact factor of 0.66, published an editorial that cited all its articles from 2005 to 2006 in a protest against the absurd scientific situation in some countries related to use of the impact factor. The large number of citations meant that the impact factor for that journal increased to 1.44. As a result of the increase, the journal was not included in the 2008 and 2009 journal citation reports. Coercive citation is a practice in which an editor forces an author to add spurious self-citations to an article before the journal will agree to publish it in order to inflate the journal's impact factor. A survey published in 2012 indicates that coercive citation has been experienced by 1 in 5 researchers working in economics, sociology, psychology, and multiple business disciplines, and it is more common in business and in journals with a lower impact factor. However, cases of coercive citation have occasionally been reported for other scientific disciplines.
Responses.
Because the impact factor is not always a reliable instrument, in November 2007 the European Association of Science Editors, EASE, issued an official statement recommending that journal impact factors are used only, and cautiously, for measuring and comparing the influence of entire journals, but not for the assessment of single papers, and certainly not for the assessment of researchers or research programs. In July 2008, the International Council for Science, ICSU, Committee on Freedom and Responsibility in the Conduct of Science, CFRS, issued a statement on publication practices and indices and the role of peer review in research assessment, suggesting many possible solutions, for example, considering a limit number of publications per year to be taken into consideration for each scientist, or even penalizing scientists for an excessive number of publications per year, for example, more than 20. In February 2010, the Deutsche Forschungsgemeinschaft, German Research Foundation, published new guidelines to evaluate only articles and no bibliometric information on candidates to be evaluated in all decisions concerning performance-based funding allocations, postdoctoral qualifications, appointments, or reviewing funding proposals. Increasing importance has been given to numerical indicators such as the H-index and the impact factor. This decision follows similar ones of the National Science Foundation, US, and the Research Assessment Exercise, UK. In response to growing concerns over the inappropriate use of journal impact factors in evaluating scientific outputs and scientists themselves, the American Society for Cell Biology together with a group of editors and publishers of scholarly journals created the San Francisco Declaration on Research Assessment, DORA. Released in May of 2013, DORA has garnered support from thousands of individuals and hundreds of institutions who have endorsed the document on the DORA website.
Other measures of impact. Related indices.
Some related values, also calculated and published by the same organization, include immediacy index, the number of citations the articles in a journal receive in a given year divided by the number of articles published, cited half-life, the median age of the articles that were cited in journal citation reports each year. For example, if a journal's half-life in 2005 is 5, that means the citations from 2001 to 2005 are half of all the citations from that journal in 2005, and the other half of the citations precede 2001. Aggregate impact factor for a subject category, it is calculated taking into account the number of citations to all journals in the subject category and the number of articles from all the journals in the subject category. These measures apply only to journals, not individual articles or individual scientists, unlike the H-index. The relative number of citations an individual article receives is better viewed as citation impact. It is, however, possible to examine the impact factor of the journals in which a particular person has published articles. This use is widespread, but controversial. Garfield warns about the misuse in evaluating individuals, because there is a wide variation from article to article within a single journal. Impact factors have a large, but controversial, influence on the way published scientific research is perceived and evaluated.
PageRank algorithm.
In 1976 a recursive impact factor that gives citations from journals with high impact greater weight than citations from low impact journals was proposed. Such a recursive impact factor resembles Google's PageRank algorithm, though the original Pinsky and Narin paper uses a trade balance approach in which journals score highest when they are often cited but rarely cite other journals. Several scholars have proposed related approaches. In 2006, Joan Bolin, Marco A. Rodriguez, and Herbert van der Sompel also proposed replacing impact factors with a PageRank algorithm. From their paper, based on 2003 data. The table shows the top 10 journals by impact factor, PageRank, and a modified system that combines the two, all based on 2003 data. The eigenfactor is another PageRank type measure of journal influence, with rankings freely available online. So is Simago.
Article level metrics and altmetrics.
Alternative metrics, or altmetrics, often measure impact at an article level and include article views, downloads, or mentions in social media. As early as 2004, the BMJ published the number of views for its articles, which was found to be somewhat correlated to citations. In 2008 the Journal of Medical Internet Research began publishing views and tweets. These tweetations proved to be a good indicator of highly cited articles, leading the author to propose a twimpact factor, which is the number of tweets it receives in the first 7 days of publication, as well as a twindex, which is the rank percentile of an article's impact factor. Starting in March 2009, the Public Library of Science also introduced article-level metrics for all articles published in the year prior to Volume 1 are known zero values. Journals that are indexed starting with a volume other than the first volume will not get an impact factor until they have been indexed for 3 years. Annuals and other irregular publications sometimes publish no items in a particular year, affecting the count. The impact factor relates to a specific time per paper published in that journal during the 2 preceding years. For example, if a journal has an impact factor of 3 in 2008, then its papers published in 2006 and 2007 received 3 citations each on average in 2008. The 2008 impact factor of a journal would be calculated as follows. Note that 2008 impact factor was devised by Eugene Garfield, the founder of the Institute for Scientific Information. Impact factors are calculated yearly starting from 1975 for those journals that are indexed in the Journal Citation Reports.
Calculation.
In any given year, the impact factor of a journal is the average number of citations received. Factors are actually published in 2009. They cannot be calculated until all of the 2008 publications have been processed by the indexing agency. New journals, which are indexed from their first published issue, will receive an impact factor after 2 years of indexing. In this case, the citations to the year prior to Volume 1, and the number of articles published.
Impact factor.
The impact factor of an academic journal is a measure reflecting the average number of citations to recent articles published in the journal. It is frequently used as a proxy for the relative importance of a journal within its field, with journals with higher impact factors deemed to be more important than those with lower ones. The impact